and we are going to introduce you to a webinar where we talk about the efficient frontier for LLMs. Simply put, we're going to talk about the frenzy in the enterprise for AI adoption and what it entails for you in terms of cost, quality, and mainly security and the quality of the results that you get from deploying each of these LLMs. To be able to take you through this webinar, we have our CTO, Ranjit Padmanabhan, who is going to take us through various aspects and considerations that you need to keep in mind while choosing these LLMs, and what challenges and considerations we kept in mind when we started deploying our own GenAI infrastructure on our enterprise. Without much further ado, Ranjit, over to you.
Thanks, Ranga, and thanks to everyone who's joined. Thanks for making the time. So my goal is to spend maybe the next 40 to 50 minutes with you discussing some of the capabilities that we have here at Automate, but mostly focusing on some ideas that we have built and that we're taking forward as as we join this generative AI revolution. So let me get started by giving you a little bit of description of what we do at Automate, and this will give you an idea of why we're approaching these problems, why these problems are important for us to solve. So at Automate, we have our slogan is enabling the autonomous enterprise. And what this really means is that over time, we believe that very much just in much the same way that vehicles became autonomous, enterprises can become autonomous by becoming self-driving, learning, and having the ability to change course based on real data. So that's the high-level idea. And today I wanted to talk about how we can start using LLMs and the capabilities that they bring into the whole idea of the autonomous enterprise and into workflow automation, which is our core capability. So around this, I want to talk about the concept of an efficient frontier, and I'll explain what this means, and I'll show you a few slides and a few demos. So just I wanted to spend maybe 3 to 5 minutes describing what we do at Automate. So as indicated on the slide, we hyper-automate enterprise workflows. And hyper-automation is kind of a loose term. It was defined by Gartner a couple of years ago. But the idea is that it's an aggressive approach to automation where everything that has the potential to be automated is, and this includes everything ranging from voice to text to customer interaction to backend processes and all of that. And by doing this, we help save our customers to save time, to save money, and specifically to one of our key segments, which is the financial segment. We enable them to be flexible with change and maintain compliance with regulations. So first of all, just a high level, bird's eye view of the platform we offer. So we offer what is called an intelligent platform as a service. And what this means is that we give customers, and in this case, enterprises, the capability to build and deploy their own workflows. And these are end-to-end workflows starting from when a customer initiates an engagement with the enterprise all the way till when that, whatever issue they came with has been resolved. And so broadly, we have 3 key capabilities in any workflow. We think of it as a customer journey. The first element of this is what we call the intake process, whereby a customer comes in and engages with the enterprise, and they can come in and do this through many different channels. They can come through a virtual agent like a chatbot, live agent, through mobile apps and all of these kinds of things. And so we provide a suite of low-code tools that enable enterprises to shape this front-end experience. Once the information comes in through the front end, we have a back-end a powerful workflow engine that can use the information that came in and resolve the customer's problem. So for example, if someone's applying for a loan, they would enter information about the loan through a bunch of different channels. And then once this information was collected on the back end, they could put into place many different workflows like credit checks and salary checks and financial appraisals and all of that. And these can integrate with backend systems so that the entire loan application can be carried through from start to finish, and eventually a decision gets sent back to the customer. During this process, we also provide significant analytics capability with a bunch of off-the-shelf tools as well. Now, the reason I'm telling you this is that what we've done is, as we saw over the past 18, 24 months, as we saw the wave of generative AI coming along, we uh, have started to infuse the capabilities of Gen AI into our platform. And so I wanted to give you a little bit of a breakdown of how we do that. If you look at the high-level modules that are present in our platform, there's front-end capabilities, low-code tools to build front-end experiences. You can build conversations with AI Chat, you can build apps with AI Solo, and you can manage, you can have the human interaction, human in the loop through the AI Live product. And then on the back end, you have AI Studio, which is kind of the umbrella tool with which enterprises can design these journeys. AI Flow is our backend engine that enables you to create and deploy business processes. And finally, all of this is built on top of an analytics engine that gives you reports, analytics, and those kinds of things. So we saw the promise of Gen AI a long time ago, and we've infused it into every stage of our low-code platform. So every screen in our platform allows you to enter a prompt, whether it's to generate code, whether it's to create workflows, whether it's to create SQL queries for reports, or to create user interfaces. And most of these tools are out, and a few of these are coming out in the next couple of months. So Gen AI is important. And so I wanted to start getting into what Gen AI means, and how you can efficiently use LLMs when you're using Gen AI. So if you look at how Gen AI has impacted companies, everyone's excited about the capabilities and the promise of Gen AI, but they're a little bit hesitant about some of the underlying issues related to cost, related to security, and related to integration with legacy tools and things like that. So these are some of the challenges that we're trying to address, and I'll talk about some of the ways we address these challenges in today's webinar. So to get into that, I wanted to introduce this idea of an efficient frontier. Uh, an efficient frontier is an old term that's been used by the stock market. And the idea is that at any given time, you want to have a portfolio of stocks that manages the risk and reward of your investments in a way that's most suitable for you. So that's what it is. So to maintain an efficient frontier, what you want to do is you want to have the ability to buy and sell stocks, for example, uh, uh, with on a continuous basis, so that you maintain this proper ratio of risk and reward. Now we are taking the idea of the efficient frontier and applying it for using large language models. When people, like I said, some of the challenges around using LLMs are security, cost, quality, and speed. These are the four challenges that we've identified. And what we've done is we are building sort of an adaptive framework that has access to multiple models that allow you at any given time to decide what's most important to you. If you decide that cost is most important, we can balance cost by using the models that will give you the highest quality at the cost that you prefer, and things like that. So the idea is that just like you have risk and reward being balanced in the world of stock, in the world of investing, you have security, cost, quality, and speed being managed through this efficient frontier that we're building for large language models. So one of the key lessons of using these large language models is that you need to have a diversification strategy. If you buy stocks, you don't put all your money in one company. What you do is you diversify. And you need to diversify in the same way when you're investing in large language models. You need to decide which one is suitable for which use case, and you need to have a flexible approach to acquiring these models, integrating with them, and deploying them. And you can see that some of the large vendors are supporting this idea. So Google has this thing called the Model Garden that allows you to bring up servers with different open source LLMs and things like that. Microsoft has Model Catalog and so on. So the point is, you should use the LLM that's best suited for your problems. You should use as many of them as you need, and you should not get locked into any one particular solution. So just for illustrative purposes, I've given you a bunch of different criteria using which people can evaluate LLM. So if you want something that's instructional, if you want something that has the ability, say in a customer support situation, to take a problem and give you instructions about it, there's LLMs tuned for those kinds of purposes. There's multimodal models, which means that they can deal with image, text, voice, all of those kinds of different types of data, and so on. So there's a whole bunch of them that I've listed here, but I just wanted to show you this list because there's a diversity of criteria that may be important to you, and there's a large number of models that will probably satisfy your requirements. I wanted to quickly take you through our approach that we use and that we make available to our customers when it comes to applying this efficient frontier idea. So our approach is that we provide you with the infrastructure that allows you to specify what's important to you. And then based on your use case, let's say you decide that cost is important, security is second most important, and maybe the speed of response is third. So what we do is based on that, we have a framework that can use and deploy and configure the appropriate LLMs that you need to meet those requirements. So as an example, some models are costlier than others. You may want to avoid those if you're cost conscious. Some are slower than others, but maybe better. And you might want to avoid that if you want to have a quick response for your customers. So this picture basically shows you that there's an infrastructure that sits between the customer and the LLMs, and we manage that infrastructure for you. And this infrastructure allows you to minimize cost, optimize security using many different approaches, maximize quality, and maximize speed. I wanted to get into a few demos here just to show you how something like this would work. So, so the first tool I wanted to show is an LLM tracker. And the LLM tracker allows you to explore and track and use different LLMs to see which one is most suitable for your use case. And along with that, as you start to use them, we give you information on costs and performance and quality and things like that. And so we have a simple demo that is connected to all the models, all the LLMs that have been listed here. And I'll show you how this works through an interactive example first, and then by using a real-time dashboard and running a bunch of queries just to show you how this concept works. By the way, Ranga, if people have questions, let me know.
I'm keeping track of that, Ranjit.
Okay.
And by the way, in the audience, if you have any questions, please don't wait for the end of the session. Please keep them coming in the Q&A widget, and I will route them to Ranjit for you. Thank you.
So the first thing I wanted to show you is this dashboard here. So this dashboard at any given time shows me. So think of this. Maybe there's an enterprise that has a bunch of different teams, each of which is using different models. So what this dashboard does is it collects data from many different models and gives you a real-time view into what's going on, kind of split into three key areas. The first one is the response time and the speed. So you'll see at this moment, the model Text Bison, which is a Google model, is doing the best, and the 70 billion, the large model of Meta Llama, is not doing that great. Likewise, in terms of quality, you have some of the GPT tools right on top. And the third one is in terms of cost. You have kind of almost flipped where you have some of the Llama and Mistral tools giving you best pricing. While some of the Google tools sit in the middle of the pack and the GPT tools are lower down. So let me show you how this works. So this is a dashboard that we have, and I'll scrunch that dashboard up for a minute, and I'm going to show you a tool called the LLM Explorer. So this is just a simple tool that we have, and we can pick any LLM that we want. So let's say we go with Text Bison. So I'm going to pick Text Bison. I'm going to very randomly copy and paste a query from uh, from a collection of queries that I have. And I've never tried these queries before. I'm just copy pasting it from a corpus of queries. And so as this query gets run, you'll notice that this number changed from 137 to 138. And in addition to being able to run the query, I got how much my query cost me, the response time in milliseconds, and the quality, which is zero point 0.8. Quality is measured on a scale of point I guess 0 to 1, and so zero point 0.8 is pretty good quality. And so you'll see that this was reflected in this dashboard. So the next thing I'm going to do is run. Just give me 1 second here. Uh, a set of queries that I'm going to run about 10 queries where, the way we have it set up is that the system automatically just picks from a corpus of like 25,000 queries, randomly picks model, randomly picks a query and runs them. So I'm just going to run that now. And our dashboard, I've set it to refresh every 5 seconds. So I'm going to run these 10 queries one after the other. And as they run, you should start to see the dashboard changing. Yeah, the most obvious one will be the change in the number of prompts. But as you go forward, you should also see the cost slowly creeping up. This shows me the most recent query that was run, and you'll see that maybe here and there the leaderboard, some elements of the leaderboard start to swap and things like that. But what you have is you get a good bird's eye view of which models are working in terms of response, what your total cost is. And so just to explain this dashboard a little bit, this one shows you, I have 11 different LLMs that are currently accessible. This shows you the average response time. Obviously, Text Bison is really doing very well. This is a Google one. There's the GPT ones, which are from OpenAI. Gemini Pro is the next gen Google LLM. And then Text Bison, there's a 32K version and the regular version. Mistral and Mixtral are both variations of the Mistral tool from a French company. And then you have the two llamas, the 13 billion parameter one and the 70 billion parameter one. You'll see that this guy is not that fast. And then we have a bunch of other tools. You have different versions of GPT and a few. And Text Unicorn is actually allegedly the most capable model that Google has, but it's not doing that great from a timing perspective. So this is the leaderboard for response time. This is a leaderboard for quality. The quality stats are, don't take them too seriously. It's somewhat made up. I have a very lightweight way of figuring out what the quality is. The correct way to figure out quality is to actually get user feedback. So don't take this one with a grain of salt. And then this is the actual cost. So you'll see that in terms of cost, the Mistral and the Mixtral ones are the least expensive, and GPT-4 is the most expensive, and this is in terms of the average cost. So if you look at these little stats here show you for each what is the total that you have spent for each model. I mean, for these 146 queries. So you'll see that out of having, and this is in US dollars, so having spent 45 cents, uh, you know, almost half of that is consumed by GPT-4, and then about a quarter of that is consumed by GPT-4 Turbo. And then you have small contributions from a couple of the Google models, but all the rest of them are, consume only a very small amount of cost. So when you look at this picture, a couple of things come to mind. The first one that's very obvious is that when it comes to response, the Google Text Bison model is doing pretty well. So the Text Bison model is on top, average response time for, and these are, I'm sending queries that have about maybe 20, maybe even 40 tokens. And so for these queries, it's doing a really good job. Text Bison you've not even used 1 cent so far for all the queries. Yeah, it's in terms of quality, like I said, don't worry too much about this. Here, it's sort of in the middle of the pack when it comes to costs. So if you had to just based on this pick a particular LLM, Text Bison would probably be a pretty good choice. GPT 3.5 Turbo is pretty good. It's better than Text Bison in terms of cost and just a little bit behind in terms of response time. Pretty good in terms of quality and so on. So what a chart like this allows you to do is, decide which tool is best, and then you can further subdivide and drill down based on different criteria, and then say that okay, when I'm doing large queries, I want to use this model. When I'm doing short queries, I want to use this model. When I'm using multimodal, I want to use this one. So uh, uh, all of uh, these kinds of decisions can be made based on this data. So the way our efficient frontier infrastructure works is that we look at all the data that's coming up from all the different models, and then based on what you decide is good for you, we can pick the model that will satisfy your requirements. So this is the first demo that I wanted to show. Let me go back to my PowerPoint. And the highlight is that we have a real-time dashboard, and it can adapt to all your business metrics and things like that. Just to give you guys a little bit of a view into LLM pricing. As of today, the pricing looks like this for 1,000 output tokens. And so you can think of a token as being approximately, I think, 3.5 characters. So 3,500 characters, I suppose, for 1,000 of them, where you're paying with some of these models like GPT 32K, you're paying a lot of money. And this, if you're doing a million queries or whatever, this money can add up really fast. This is not zero. This is obviously some bug. But anyway, so these are the numbers that uh, that we have: GPT 32K, GPT-4, and then the most expensive Google model is the Text Unicorn, but the others are relatively inexpensive. Gemini Pro is their newest model, and as you can see, it's quite inexpensive. Um, so just to kind of summarize this whole point on cost control, uh, one of the challenges that enterprises have is that the cost for LLM use, it can add up very quickly. Uh, if you decide that you want to host your own large language model, you're looking at a high capital expense to put this into your data center. Of course, if you're doing millions and millions of queries, that starts to pay for itself, so you get the ROI. But if you're not doing that many queries, it's not the cost of actually running your own model in-house is high. So our approach is that we try and solve the bigger problem. We're not just focused on costs in by themselves. We want to solve the bigger problem of how can an enterprise comfortably deploy models. And so we're looking at when you augment these models with workflows. So let's say a question, you get a response from a mod from an LLM that's not to your liking. You can actually divert it off to a curation workflow that is supported by our workflow tools that can people can contribute a better answer and then put that back into the database. And from that point onward, you don't even need to go to the model and incur the cost of that model in order to get an answer to that question. We can do things like caching results. You can do uh, you know uh, setting up a very dynamic model where, depending almost on the query, you can pick which LLM to use and so on. The next so that's the first demo. So since we're talking about use cases and the best LLMs to use for specific use cases, I'm going to walk you through a couple of examples of what we've done. The next demo I wanted to show you is for agent assessment. The idea here is that many companies, when they have agents, they want to have a way to assess how well the conversation between the agent and the customer went. So they generate transcripts of these calls, and then a supervisor reviews these transcripts, and generally they review them against some rubric or some set of questions that must be answered, and make an evaluation of how well the agent did based on that. So what we built is a chat-based example of agent assessment. And the model that worked best here was Gemini Pro. And some of the features that made it useful was the speed, the quality, the cost, and it takes a good number of tokens, because chat transcripts, conversational transcripts can have a lot of text in them. And it was, very simple to train and configure these in less than a week. So I'm going to show you this demo. So I'm going to show you the agent assessment demo, and I'll show it to you with a couple of examples. Okay, so the first thing that the agent assessment bot asks for is, so I'm just going to be copying and pasting this information from another screen. So it says, please provide the agent transcript. I'm going to, let me just, I hope you can all see my screen now. So this is the transcript. So as you can see, it's quite long, and then we have the questions at the end. So I'm just going to copy the text from the transcript and paste it in here. And so I've pasted the transcript. The next thing I'm going to do is paste in the questions. And these are the questions, or this is sort of the rubric against which the quality of the conversation is measured. So I'm going to copy that and paste that in here. And I'm going to hit return. In this case, we have the example we've picked is a polite agent who's done most of the things pretty well. And we hope that the results, that the assessment from the chatbot reflects that. So as you can see, it presents the results in a very human-friendly way. It looks at all the questions and gives me a question by question itemized response. It says, was the CSA able to open and close? Yes. Yes, they were polite. Did they respond appropriately? Did they summarize everything? Uh, did they resolve the customer's concern promptly? And all of these kinds of things. So the tool was able to do this, which is pretty remarkable. And the having the ability to just make a tool like this available to our customers through our chatbot is one of the capabilities that we bring to the table. So I'm going to try another one. So the first one was what you might call a polite agent. The second one is going to be a not so polite agent. And I'm just going to show you this. So the agent starts by saying, I'm in a hurry, please don't waste my time. And then the makes a bunch of spelling mistakes, and then says, uses garbled sentences like this and things like that. So I'm just using this as an example of just to see if the agent assessment is able to actually realize that this is not a very good agent. So I'm entering the transcript, and then I'm going to enter basically the same questions. Okay. So we'll give this tool a little bit of time. And let's see what it comes back with. So in this case, correctly, the assessment was generally negative, though there were a few highlights. So for example, the CSA was not warm or engaging. They started the conversation by saying they were in a hurry not to waste their time, which created a negative impression from the outset. According to this, the questions were relevant, and this is probably true, and that they responded appropriately and assured them, and a few other things. But then when it comes to creating a great experience, no. Positively represent the merchant, no. And did the CSA use the customer's name, no, and things like that. So as you can see, the tool was able to actually give a almost human-like assessment of this of the transcript. And Gemini Pro has shown itself to be really powerful in this sense. Like I said, in terms of capability, in terms of cost, in terms of speed. And the best part is it's a multimodal type of model. So I could have taken the same information as voice and submitted it to the agent assessment tool, and it would have been able to provide a strong assessment, because that's what the Gemini Pro model is capable of doing. So let's come back here. So we used our LLM manager here as the infrastructure that allows you, that sits between the chatbot and the backend LLM. The next tool I wanted to show you is around email automation. And here again, we found that Gemini Pro does a very good job. But to be transparent here, we used a combination of Gemini Pro and OpenAI GPT for the next demo that you're going to see. So for this next demo, I'm going to be a customer who's writing an email to to a customer support of a particular company. And the scenario is that we're talking about a company that deals with SIMs and mobile phones. And so this person is going to send an email asking a particular question. And that the way that this tool works is that uh, normally when an agent gets a question like this, what they do is they go pick up some information from their knowledge base. They may look at any public sources of data. They combine all of this, put it into an email, and send a response back to the customer. We're going to try and automate all of that. So, my identity here is William Chen, and William is going to be sending a message uh, to an email gateway, and I'll kind of explain how this works. So, uh, so maybe I'll just say subject to SIM not working, and I'm going to say my SIM has been activated, but can't make or receive calls. That's all I'm going to do. Just send this particular message. So I'm going to send this message, and what I'm going to do is we're using an email gateway from Pipedream, and so I'm just going to keep an eye on this email gateway. So you'll see that the email has come into this gateway. And so basically, like I said, just to recap, so what the tool is going to do is it's going to pull information from many different sources, assemble it into a nice, uh, user-friendly email response, and send an email back to the person who sent the question. So this is still working. And then hopefully, if it goes green, that means, it's all the appropriate services went through properly. So I'm going to come back here now, close this, and you'll see now that this guy's got a response. And when I click this response, you'll see that it's actually doing a fairly comprehensive assessment and of all the data. So it's pulling data from the so it does a few things. First thing is it personalizes it. It knows who sent the email. It generates what we call a generative summary. So this is the top level summary response to the email. It then picks the best results from the knowledge base. So these are here, and for each result, it gives you kind of a summary as well as what we call a generative snippet. What this means is that it pulls one or more snippets from the document, connects them together into a response, and sends it back to the user. And then it also found that there's public information available on the web. And so it creates, again, kind of a summary or a generative response of the public information, and then gives you links to the top sites from where this information was gathered. So for example, if I click on this site, it takes me to the page where, there's some response to what to do when your SIM is not working. So this is the email automation, and again, we use the Gemini Pro model for this. Um, so
Ranjit, would you
the
mind? Sorry to interrupt you, but would you
Yeah,
mind taking a question while you're on the flow, or would you want to
yeah, no
park it
problem.
for the rest? Yeah, we
Yeah,
just
go
have a
ahead.
question saying if we detect bad quality responses for a given LLM, how do you fix it?
Okay. So one of the ways that you deal with okay, let me back up a bit. Anytime you roll out an LLM, you have to give it a period of probably 30 to 60 days to evaluate the quality of the LLM and to tune it so that it gets to a stable, high quality state after that time. And so what you do is you have a human or you have people look. I mean, you have either a human intervention or you have some other mechanism to evaluate the responses that come back from the LLM. And then what we propose is using sort of a combination of automated tools where you can look for certain keywords in the response and make sure all those keywords are covered, and human intervention where you can actually take this message, take the response, send it to the backend, get it curated, and have someone actually create a better response for the particular question that came in. Once you create that response, you can just keep it locally in your knowledge base, and so you don't need to go back to the LLM each time that question comes up. And so no, so you do two things: you save money and you get a better quality response. So that would be the approach.
Awesome.
Yeah.
Thank you, Ranjit.
Yeah. Thanks, Ranga. Uh, okay. So the next, I think the last, and this is the last demo I want to show you, is to before I get into that, I want to kind of give you an idea of some of this issues around security with LLMs. This has obviously, been a major point of discussion, and the people are worried about proprietary data going into third-party models being used for training, PII being revealed, and also an important one is to figure out, and handle or minimize misinformation. These are some of the challenges that people have from a security perspective. So we are taking a few different approaches to support this, and we expect to be rolling out more and more of these capabilities in the rest of this year. But from the perspective of what we do, at the first level, we make sure that all data is encrypted. So this is the first level of security. It's standard. You want to make sure that you use HTTPS or in and out. You want to make sure that data, when it's stored in a database, especially user data, is encrypted. Um, the second point is all around protecting PII information. And what this means is that ultimately, the meaning of PII is nobody should be able to, based on the information that they have been given, they should not be able to figure out who this person is. That's basically PII protection. So, in some cases, you need to, uh, you know, make information vague. In some cases, you have to remove information and things like that. So, for example, if I have a phone number, it's pretty likely that I'll be able to figure out who the person is. So you want to be able to have the ability to redact phone numbers. There are a couple of interesting ideas around this area. One is called differential privacy, and the general idea is that and this goes sort of hand in hand with a fancy named approach called homomorphic encryption. The general idea is that you anytime you send the data uh, to a third party and you don't want that data to be disclosed, you disguise that data so that from the outside to the third party, it looks like normal data and they treat it as they would any normal data. But uh, it is actually not revealing any information about the person or any personal information. So that's the whole idea here. And this is what I'll show you a demo about. And then the third aspect is to use, various techniques like setting parameters or RAG and tools like that to reduce hallucinations, to put guardrails around your data to make sure it doesn't go off out of scope when it's answering questions and things like that. So I wanted to show you a simple demo, and this is sort of a, you can say engineering friendly demo, because it's dealing with an issue, it's not a UI issue or anything like that. It's basically a way for you to, uh, you know, uh, to protect information. So I'm going to show you a couple of examples. So when we talk about data encryption, what we do is we give users the ability to decide what they want to do when you see certain types of information in a query. So in this case, the configuration has been set so that anytime you see a location, you substitute it. Anytime you see a number, you encrypt it. You substitute the person's name, you redact the phone number, and then you encrypt any information that's price like. So there are a few challenges here. So for example, you have to detect all these kinds of, they call these things entities. You have to detect all these entities in the text first. Once you detect these entities, you have to apply these rules, and then that the information that you then end up sending to the LLM is disguised and does not reveal any personal information about the person who's actually, asking the question. So I'm going to walk through this in a few stages. So this is the configuration. Um, so let's say this user query looks like this. In San Francisco, Dave Johnson bought 4 apples at $1.20 a piece. He can be reached here. Where did he buy apples? This is obviously a very silly question, but I've just created this to make a point. This is a location, for example. This is a person. This is a price/number. This is a phone number, and all of that. So I'm going to continue and show you how this system works. So the first thing it does is it extracts these entities, these little pieces of these little nuggets from within the sentence. It's able to extract the price, it's able to extract the number, it's able to extract the phone number. And so now once you do that, then you can apply the rules. You can say, I'm going to redact this, I'm going to substitute this, and things like that. So the actions that need to be taken are encryption on the numbers, redaction of the phone number, and substitution for the person and location. So to do this, you have to create what's called an encryption map. What this means is that anytime you're doing a substitution and sending information to a LLM, when the information comes back, you want to map it back to the normal values so that you can send the appropriate information back to the user. So you create an encryption map that is used for reverse mapping the response that comes from the LLM. So this is the user query. In San Francisco, Dave, all of this stuff. But the encrypted query that you send to OpenAI is you've substituted the name and the location. You've encrypted the numbers. In other words, you've used different numbers, and you've redacted the phone number. For this particular question, this works. So this query then gets sent to the user, and the response comes back and says, Andy Smith bought apples in New York. You then apply the reverse mapping, and then you say, from the encryption map, you sort of decode it, and then once you decode it, you can send the actual response back to the user. So this is one example. The second example I wanted to show you is a little bit different. So it's a similar kind of sentence, but in this case, we actually want to do something with this information, which is 8 apples for $1.25 a piece. How much did he pay? So in this case, you cannot encrypt this information, or at least there are tools where you can potentially encrypt this, but if you take the normal approach, you cannot encrypt it, because then the value of how much he paid will get modified. So again, same kind of idea. So this is the user query. We extract the entities, and in this case, we're not encrypting the text information. And then the same thing happens. You substitute the person and the location. You create this encryption map. This is the user query. You convert it here, but you're not disclosing who bought these apples. All you know is that these apples were bought, but you're not giving away the location or the name of the person. And then you get the response back, and then you use the map to decrypt the response and give this back to the user. So these were this is just a simple illustration of techniques that we can use to protect PII from actually going to these third-party LLMs. And so, as just as a quick note, this is user configurable. We use data substitution, redaction, and encryption. And so, I think we're coming up on time now. So that's all I
That's right,
had from a
Ranjit.
demo perspective. We have a couple of more demos, but we'll probably put them on videos or something like that so that you can have a look at them later.
That works. And we also have a new question. I believe it was sent before the security demo started, Ranjit.
Okay.
I think the question here says, those two examples were text-based. How do you deal with multimodal data?
Yeah. So
And
so
would you
what?
also mind explaining a bit more than the initial introduction what multimodal data means for the audience, Ranjit?
Sure. So multimodal data basically means data that's voice, text, voice, images, audio, video, all of that stuff. So this is a mixture of data that comes from many different sources. Generally, the approach that you take with multimodal data is different depending on the type of data. Earlier, it used to be that you would translate everything into text and then operate in a text-based manner. But now there are tools that have been developed by some companies that can redact information on the fly. And so you can take a voice stream, delay it by maybe a couple of seconds, and then what ends up happening is that you can actually detect when people are giving personal information or giving names and things like that. You can redact it and send that information, to the third party. That's the best that you can do now with voice data. There's no easy way or no company or no tool that I know that can deal at the moment with video data. So you have to use some other techniques like maybe transcribing it into text and then doing it or something like that. But that's the idea. So for example, phone calls, you can redact and you can apply many of these techniques to it. But when it comes to video streams, it's very hard to redact.
I hope that answers that question, Ranjit. We don't have any
Yeah.
more new questions. Any specific points that you wanted to add while closing your presentation, Ranjit?
Yeah, I mean, one of the key points I want to make is that, so we have this, this is the architecture of the future that we are that we are planning to have at Automate. And the idea here is that, we want to give you choice. We want to give you the ability to choose the LLM that's most suited for your use case. And the idea is that at the moment, the way we're doing it on a use case by use case basis, we're deciding which model should be used. But as we go forward, we want to get to the point where even on a query by query basis, so maybe a short query in a different language might trigger a different LLM to be used as opposed to a long query in English or something like that. So we look at a bunch of different features around the incoming query, and based on that, we'll choose the LLM that's most suited for responding. So I just want to make the high level point that don't get locked in to any one LLM. Keep your options open.
Fantastic. Any more questions from the audience before we call it a wrap? Going once, going twice. All right. If there are any more questions and you are not able to get to the webinar on time, please don't worry. The webinar is being recorded. You will get a link to the recording shortly after this presentation. And if you still have any questions, please reach out to us through the same email that the recording was sent to, and the team will route it to Ranjit and get your queries answered. Thank you so much for orchestrating this seminar for us, Ranjit, and we want to make sure that we also announce that we will be taking the audience through a series of webinars. So stay tuned for our further announcements this month and the next, and we'll be happy to take up any more topics that would be of interest to you. Thank you so
Great.
much and
Yeah.
have a good day.
Thanks to all the attendees and thank you, Ranga.
Thank
Bye.
you. Bye. Bye, everyone.